Okay, everyone, welcome to the 3.06 collaboration. My name is Mr. DeSimone, and working with me today will be Mrs. Ortega and Mrs. Robb. You can use the chat box that's at the bottom of the screen that is available to you right now. So if you have any questions as we go through the explanation of what you're doing today, just please type those in the chat box below. Before we start, I just want to make sure all of you can hear me. So please give me a smiley face if you can hear me. The smiley face is the first button underneath your name. So if we can all get a smiley face. All right, and leave that smiley face up for just a minute, just so I know you can hear me. Okay? So, like I said a couple of moments ago, for those of you who didn't hear me, please, you should have already completed lessons and assignments 3.01 through 3.05. You can use your notes. We will give you microphone privileges once you get into the breakout rooms. And right now you can use the chat to communicate any questions. Okay, those of you who have their smiley faces up, you can put those smiley faces away for now. One more thing, all students must participate in this collaboration. Okay, so you're going to need to make sure that you can communicate with the other students in the breakout rooms. Okay, so why don't we get started? We're going to make sure that you understand how to use some of the tools we'll be using today. So at the top of the page, you will see there is there's a sidebar on the left side of your screen, and at the top of that sidebar, you will see an arrow. If you click on that arrow, that will allow you to move text around. That will allow you to move some of the things around during the collaboration that we'll show you in a few minutes. The fourth button down, you'll see an A with lines going across. If you click on that A, and it'll make a capital A, click on the capital A, and you can type your name anywhere on this blue slide. So I'd like you to do that. See if you could type your name. And once you type your name, click on the arrow at the top and move your name to the right side of the screen. So if everybody can start writing their name, that would be great. You don't have a sidebar. Okay, well, one moment. There should be one there now. You should have a sidebar now on the left side. Okay, yeah, the tools are a little bit slow getting started. Okay, once you type your name in, please move your name over to the right side by using that arrow key at the top. We'll make a nice, neat row of names. Okay, I'll give you about another minute. Did everybody get their name written? And then just use the arrow at the top and slide your name over to the right side. So let's see, Eva, Sean, Bristol, Spencer, Clark, Jack. If you can move your names over to the right side, just want to make sure that all of your tools are working. Okay, great. All right, we are going to go on to the next slide. All right. And this next slide is an attendance slide, and you're not going to fill out this attendance slide here, but when you get to the breakout rooms, this will be the first slide you see. So what you're going to do is you're going to make sure you fill this out. You're going to put your first name, your last name, your teacher's name, and your username. Okay? see a bunch of you are raising your hand for some reason. No, we're not filling this out yet. Do not fill this out. Who's ever filling it out, please do not do that. All right, we're not filling this out. Please do not fill this out. Okay, this is for when we get to the breakout rooms. Okay, so if you put your name up there, please erase it. Thank you. All right, thank you very much. Okay, so you will fill this out when we get to the breakout rooms. Okay, so when we get to your breakout room, you'll put your first name, your last name, your teacher name, and your FLVS username. Okay, so let's go to the next slide. All right, and this is the brief introduction on what you're going to do today. All right, today you're going to work on 3 proofs. The first proof is an angle proof. Okay, and we're going to prove that 2 angles are congruent. Okay, the second proof you're going to work on is a triangle proof. We're going to prove that the base angles of an isosceles triangle are congruent. And then the last proof we're going to work on is a parallelogram proof. And what we're going to, on this one, we're going to do is we're going to prove that when we draw a diagonal of parallelogram, it forms 2 congruent triangles. Okay, and here's some vocabulary terms that you'll review today. 2-column proof. All right, 2 of the proofs we're going to be doing today are 2-column proofs, and a 2-column proof is set up like a table with statements on the left and justifications or reasons as to why the statements are accurate on the right. A paragraph proof has both statements and justifications, but it's written using complete sentences in a paragraph form. So you will see both of these types of proofs written today. Okay, so the first proof we're going to do is the angle proof. This is a 2-column proof. Now for any proof, you're always going to start with what is given. You're going to read the entire proof and look at the reasons and statements that are given. And what you want to do is you want to match the statements and reasons that match correctly. Remember to end with what you are trying to prove. All right, so here is our angle proof. And I am going to just open this up. Okay. And with the angle proof, you're going to start with what's given. And what's given is that angle EGA is equal to 120. And what you're going to do is you're trying to prove that FHD is also equal to 120. So you're going to take the answers from the answer bank. You're not going to write the answers in manually. You're just going to use that arrow key and you're going to drag the answer to the correct spot. Okay? So that's what you're going to be doing for all of the proofs. You're just going to be dragging the answers. Okay? No one should be moving any answers right now. Okay, you're going to do that once you get into your breakout rooms. All right, the next proof you're going to be working on is a triangle proof. Now, this triangle proof is going to be is a paragraph proof, so it's going to be in the form of a paragraph. Read through the entire proof before starting. Remember to start with what is given. Each space represents a word or a phrase, and remember you will end with what you're trying to prove. Okay. So here is our paragraph proof. Okay, and one thing I want to note before I forget is when you're doing your proofs, you want to make sure you put your names at the top. One person will be a writer, one will be a proofreader, and one will be a reviewer. Okay, and on this one again, you're just going to drag and drop the answers from the answer bank into the appropriate little spaces here. Okay. The last proof we're going to be doing is a parallelogram proof. Now this parallelogram proof is a 2-column proof. All right, all the statements and reasons are provided, but they're not in the correct order. So you must correctly match the statements and reason. And here's the hint. Remember this. Start with what is given and end with what you are trying to prove. So here is our parallelogram proof. Okay, in this case you'll see we have a flat screen TV is our parallelogram. Okay, and we're going to try to prove that the two triangles are congruent by rearranging our statements and reasons. Okay? So if you have any questions, we're going to go into the breakout rooms now. So if you have any questions, you can ask them when you get in there. Remember, you're going to work together with the other people in your breakout room. The first screen you will see is the attendance screen. You'll fill that out then, and then we'll move you along to the next proof. Okay, so we are going to go into breakout rooms now. We'll be with you in shortly. So just be patient for 1 or 2 minutes while we create the breakout rooms and move you into them. Thank you. We have 9 rooms, and Mrs. Rob already ran off into one of them. So I guess she went to the bottom. I'll take the top 3 if you want to take the middle 3. And then we can move around whenever.
Okay, Tom, sure, sounds good. I just went ahead and copied now the slides. I didn't
Okay.
include the ones you added. I just did the ones for them to work on. So we should be okay.
Okay. Okay. We're going to give you your tools back so you can start by putting your first name, your last name, your teacher's name, and your FLVS username, okay? So get started on that now. And once you do that, please raise your hand. Okay, you do have microphone privileges and writing privileges and chat privileges. Okay, on this screen you're going to put your first name, last name, teacher's name, and your FLVS username. Okay, and once you do that, please raise your hand. Alright, so get started with that, please. Spencer, if you can get started, and I will be back in a couple minutes. And again, raise your hand when you fill that all out. Okay, you want to make sure you have your first name, last name, and your teacher name and your FLVS username. Okay, make sure you have all that filled out. Raise your hand when you're ready. Okay, I see Stevie Marie, Sean Brown. Are you still here? Sean Brown, you need to fill out the attendance sheet. Okay, Sean, I'll give you another couple minutes. Stevie, raise your hand for me. Thank you. Okay, I don't see Sean Brown here. Sean, you raised your hand, but you did not fill out the attendance sheet. Okay, make sure you fill out the attendance sheet. So put your hand down until you have it filled out, okay? Thank you. I'm going to go check out one of the other rooms. All right, great job. You filled out the attendance sheet. We're going to bring you to the first proof. This is the angle proof. All right, so put your hands down. One of you will be the writer, one will be the proofreader, one will be the reviewer. So please type your names in, decide who's going to do what, and type your names up at the top before you begin. Remember, read through the proof first. Always read through what is given, what you're trying to prove. Read through this proof, and then you're going to take the answers from the answer bank and put them in the appropriate spots. And I'll be back in a minute. Okay, you're not finished yet. Jordan Ray, you did not put your FLVS username. Please do that so you're not holding up your whole group. You need to put your FLVS username in. Thank you. Okay, so we're going to move on to the next slide. You can put your hands down. All right, this is the angle proof. Okay, uh, make sure you get your names up here at the top. Decide who's going to be the writer, who will be the proofreader, and who will be the reviewer. Now, the writer is going to be the person who takes the lead. Everyone will get a chance to be a writer. Okay, everyone will get a chance to be a proofreader, and everyone will get a chance to be a reviewer. Okay, so Jordan, please put your hand down, and you can decide what you're going to do, and I will be back in a couple of minutes. Okay, very good. We're going to move on to the next slide now. Okay, and on this slide, this is the angle proof. We went over it a couple minutes ago. All right, one of you will be the writer, one will be the proofreader, and one will be the reviewer. Now the writer is going to take the lead. Everyone will get a chance to be a writer on the proof. Okay, so please decide who's going to do what. For now, put your hands down. Okay, so that a teacher doesn't come in thinking you have a question. So if you have your hand up, please put it down. Okay. Again, you have microphone privileges, you have chat privileges, you have writing privileges. So communicate with each other, decide who's going to do what on this first proof. Remember, everyone's going to get a chance to be the writer. Each of you are going to get a chance to do all these jobs. All right. So I will be back in a couple of minutes. Okay. Thank you. Okay, Spencer, you have your hand up. Do you need something, or you just did not put it down from before? Okay. Thank you, Spencer. All right, so I see Danielle and Spencer have their name up, so I guess, Danny, you will be the writer. Okay? So, Danny, you need to get your name up here at the top. All right, and your job will be to start writing the proof. Now, all three of you should be reading through this, okay? Remember, you're always going to start with what's given, and you're always going to end with what you're trying to prove. Okay, so this is what we're trying to prove right here. All right, is FHD, this angle, equal to 120 that you're trying to prove. You're starting off with this angle. Okay, so read through the proof. Okay, and try to figure out the missing the blanks here in the proof. Okay, so Danny, you'll take the lead on that, and Danielle and Spencer, please don't hesitate in helping Danny out. Okay, and I'll be back in a few minutes. How we doing in here? Okay, it looks like you've decided who's going to do what. Jordan, since you are the writer, you'll take the lead. Remember to read through the proof. Real quick, this is what you're trying to prove right here. That's this angle FHD. This angle here, this is what you're trying to prove is 120. You're already given that this is 120. Okay? EGA. Alright, so what you're going to try to do is fill in the missing blanks. Remember, always start with what's given. And you're going to end with what you're trying to prove. Alright, and I'll be back in a couple minutes. Raise your hand when you are done. Okay, I see Janine and Stevie, you have your name written in there. One of you is missing your name. So who is that? Sean. Sean, could you get your name under the reviewer, please? Up here at the top, if you can type in your name, that would be great. Alright, and you need to raise your hand when you think you're finished. Alright. So this is what we're trying to prove right here. Okay, which is this angle. had your hand up for a second. Sean, is there a reason why you haven't written your name up there? And Sean, when you think that we are complete, please raise your hand so I can go over this with you. Sean, I don't see your name up there. I see Stevie's name and I see Janine. I don't see your name. All right, I'll go over this. There you go, Sean. All right, now I see it now. Great. All right, so you're going to start off with what's given. Very good. All right, we're given that the measure of EGA is 120. That's this angle right here. All right. And then we said that GHC is equal to 120 because it's a corresponding angle. Very good. It's right here. These are corresponding. All right. And then GHC is equal to FHD because they are vertical angles. Very good. And that's how we prove FHD is equal to 120. Excellent job. So we're going to go on to the next slide. Okay. And well, these aren't in order, but we could do the parallelogram proof next. All right. So this is the parallelogram proof. All right. So one person will be the writer, one of you will be the proofreader, one will be the reviewer. And remember, you want to start off with what's given and what you're trying to prove. That's the hint here. All right. And then you can fill in the middle later. And I will be back in a couple of minutes. I need to go check on a couple of the other rooms. Okay, it looks like you're just about done. I'm waiting just for Spencer to put his hand up. Okay, very good, Spencer. All right, so like I said before, this is what is given. EGA is equal to 120. Very good. All right. Now, GHC is a corresponding angle. That's also equal to 120. Very good. So now you can say that GHC is congruent to FHD by the vertical angle theorem. And then FHD is equal to 120. That's what we're trying to prove. Correct. Very good job. Spencer, you can put your hand down. We're going to move on to the next proof, okay? And this is the parallelogram proof. Now, it's in a little bit different order than we showed you, but we'll just go right to this one. You'll do the triangle proof last. Okay, so decide who's going to be the writer, the proofreader, reviewer. It's going to be different people. If you've already been the writer, you will not be the writer again, okay? So we're going to start out with what is given. And we're going to end with what we're trying to prove, okay? So that's our hint. Okay? Any questions? I see something going on here in the chat. All right, very good. So get your names up there. I see you all have your names up there. Very good job. You're already getting started. Okay, very good. I will be back in a couple minutes. Okay, so in this room, does not look like we are making any progress. So what's going on, Jordan? Do you need some help? I see somebody has a microphone. Who has the microphone?
Can you hear me?
I can hear you.
Okay. We said that line EF is crossing through the other lines, but I think we do need a little bit of help.
Okay. So what did I tell you that you start with? What do you start with? And you should all be working together. If the writer's having a problem, I'd like to see the other two people helping the writer. So who has the microphone? Who's speaking?
Jordan was, I think.
Jordan was. Okay.
Yeah.
And who else has a microphone?
Say that again?
Who else has a microphone?
Oh, Brock Bergson.
Okay, Brock. So Brock and Jordan. So what do you think you start out with?
FHD.
Okay. FHD is what you're trying to prove. So you don't start out with what you're trying to prove.
Oh, EGA.
Right, EGA, okay? So did you read the proof then here below? That's already here in the statements, okay? So what's the reason going to be?
They're the same angle because they're parallel and there's an intersection through them.
Okay, but let's start off with the beginning. Okay, because you're jumping way ahead here. Look at what should go in spot number 1.
I believe would be given because what's given is technically what the statement is.
Okay, so if that's what you think it is, then move it in there, okay? So move given over. All right. Now the second line says you have corresponding angles. So what angle is corresponding to EGA? You have 4 choices here. What angle is corresponding to EGA? And that's why I said read through the proof, because the proof is going to give you hints. What do you think, Brock?
FHD?
Well, let me ask you a question. What is FHD? What are we doing? Where is that in our proof? What does it say at the top?
That. Wait. There's nothing about it at the top.
Sure there is. It says prove the measure of FHD is also 120.
Oh yeah.
So that's what we're trying to prove. So you think that's going to come on the second line?
No.
No, probably not.
Yeah,
All right.
I gotcha.
So
What
do you
about
think?
EGB? No, my bad. Never mind.
That's okay.
I'm talking about
You're allowed to think
BGH.
out loud. What do you think is what's a corresponding angle? Which one of these has a corresponding angle to EGA? Which one's a corresponding angle? That's what you're looking for.
EGF?
All right. Where's our third person? Is the third person able to help out?
Yes, I'm right here. I'm trying to figure it out.
Okay. So you're just looking for a corresponding angle. You have 4 choices. You've already eliminated 2 of them, so it's got to be one of the other 2.
Maybe BGH?
All right. BGH. Is BGH and EGA corresponding?
No.
No. So which one is corresponding? That leaves you now really 1 choice.
EGF? Wait, I'm so confused.
All right. I need to go to room 3, so I'll be back in a couple minutes to try to figure this out, okay?
Alpha.
Okay, Stevie, you have your hand raised. Let's see how you did. All right, so you're saying that what's given is ABCD is a parallelogram, correct? Okay, now we're saying that AB is congruent to CD by the definition of a parallelogram. Very good, right? Because a parallelogram, the opposite sides are congruent and parallel. And that's important because to prove the next line, BAC is congruent to DCA, all right, by alternate interior angles. So once we've established that AB and CD are parallel, we could say that BAC is congruent to DCA by alternate interior angle theorem, all right? Then the next part is AC is equal to CA. That's correct, the reflexive property. So now I have side, angle, side. Side, angle, side. Very good. Excellent job. All right, you have 1 more proof to do. Okay, and this is the triangle proof. Okay, so if you've not been the writer for the first 2 proofs, you will be the writer on this one. Now this is a paragraph proof, so basically you're just filling in the blanks. All right, remember you're going to start out with what is given. All right, what we're given is that these 2 sides are equal. All right, and this is what you're trying to prove. You're trying to prove that YXA is congruent to YZA. All right, so why don't you get started, Sean, and I'll be back in a couple minutes. Okay, let's see. Danny, you can put your hand down. All right. Now you started off with ABCD is a parallelogram. That's given, right? Okay. All right. Now let's look here. I said we need what we're trying to prove here on the bottom, okay? And you have that, but you don't have the correct reason, okay? So you need to go back and look at your steps here, okay? Because right now all you've done is this is given. You have that correct. But a side equal to itself is not going to be alternate interior angles. All right? Alternate interior angles are going to go with angles. Okay? So you need to look at the three middle piece statements and these four givens, all right? And raise your hand when you're ready, and I'll come back.
You're just gonna get something? Okay then, Johnny. What do you wanna get?
Okay, so let me stop you for a minute because you're saying that EGB is equal to 60. All right? Now, is EGB a corresponding angle to EGA? Corresponding angles are equal. Okay? One of you had already asked that question and then said, no, that's not right. So, you need to go back and look at number 2. Okay? Because number 2 is not correct. All right? Corresponding angles.
So it's either why is it not BGS then? Because that angle is the same as AGE.
BGF?
Wouldn't it be GHC?
It is, but they're not corresponding angles. Those are vertical angles. Okay? We're looking for a corresponding angle to EGA. So only one of those angles is a corresponding angle.
FHD?
No, because what did we say about FHD? What is FHD? That's what we're trying to prove.
Oh yeah, so it's definitely not that.
No.
So if I feel like number 2 would be GHC, even though.
Okay, GHC is this one. Are these corresponding? Is this angle and this angle corresponding? Take a look. What do you think?
I think they're similar, yeah.
You think what?
I think they're similar, yeah.
You think they are? Okay, so if you think that, then why don't you move it into the spot? All right. Now, if you look at line 3, all right, line 3 should have been a hint on what you put in line 2 because look what it says. GHC is equal to FHD. So you're already told that, okay? So now that you know that, how are they equal? How is this angle and this angle equal? I'm going to switch colors here. So how is this angle here and this angle here equal? By which one of these answers?
Are you saying vertical angle theorem?
Right, okay, right. Vertical angle theorem. Very good. All right, and then at the end, what are you trying to prove? Right? I've underlined it like 4. Right, very good. Okay, very good. All right, so let's move you on to the next one. The next one is the parallelogram proof. All right? In this proof, you are just going to scramble the statements or unscramble the statements and unscramble the reasons. Remember, start out with what's given and end with what you're trying to prove. All right, so get your names up here, and I'll be back in a couple minutes to see if you need any help. Okay, so do you think you have this now, Danny? So let's take a look. Okay. All right, so AC is congruent to CA, reflexive property. Right, correct. That's the reflexive property. Very good. All right. Now, here is our problem, okay? Our problem is that you matched the correct statement with the correct reason. So I could say that BAC is congruent to DCA by alternate interior angles, but I'm not ready to say that yet, okay? I need to say something else first. All right, so, and this is AB congruent to CD by the definition of parallelogram is correct. The problem is you have these in the wrong order, okay? And the reason is you have to be able to say that AB is congruent to CD by definite parallelogram, and also that they are parallel, okay? So before I could say that these two angles are equal, I need to show that these two lines are parallel. So you need to switch 3 and 4, okay? So Danny, if you could put your hand down on that. And then once you switch 3 and 4, you are correct. All right, very good. All right, so just want to make sure you understand why 3 has to come first, because we have to show that these two lines, AB and CD, that they are going to be parallel by definition of a parallelogram, okay? They're congruent and parallel. All right, very good. Excellent job. Very last one, the triangle proof, okay? So you have not been the writer. This will be your turn to be the writer, okay? And who's ever the reviewer, just raise your hand when you're ready. And I will be back in a couple minutes. Just before I forget, you are given this. These two sides are equal. All right, and you're trying to prove that y, x, a, and y, z, a are congruent. All right, that's what you're trying to prove. So remember, you always start out with what's given. You're always ending with what you're trying to prove. All right. Well, Danielle, I guess you will be raising your hand when you're finished. And I'll be back in a couple minutes. Okay, Janine, you have your hand up here. Let's take a look at what we have. So, you were correct. We always start out with what's given. We are given that isosceles triangle XYZ, where XY is congruent to YZ, okay? Now we'll construct an angle bisector. So YA is an angle bisector. All right. Now segment XY is congruent to segment YZ according to the given information. All right. We know that. And then we could say that angle XYA is congruent to ZYA by the definition of an angle bisector. Because this angle bisector divides that angle into two equal parts. Now I can say that YA is equal to itself by the reflexive property. So now I have side, angle, side. Very good. And then I can say that these two angles are congruent by CPCTC. Excellent job. Very good. So you are done. So now all you need to do is save this. Okay. So when we save, all right, when we save, what we're going to do is we're going to click on File. Okay? And then we're going to click on Save. And when we click on Save, we're going to go down here to Whiteboard. And then we're going to click on All Pages. Okay? And you can see that Mrs. Rob has just sent you the updated collaboration form. So click Yes to save that, because that will be what you're going to use. You're going to send it out for the 00.00 assignment, okay? All right, which is, you'll see down here, all right? So once you click OK, this window is going to pop up. Put in 306 in your name, but here's the important part. You need to save this as a PDF. You need to save this as a PDF, okay? Any questions? If you have any questions, you can use your microphone. You can type in the chat. As soon as you save this, you can leave. Now remember, this is what you're turning in for the 3.06 assignment. You're turning in this PDF as your 306. All right? The form that Mrs. Rob just sent you is what you're turning in for the collaboration assignment, which is that one. It's the very first assignment at the top of the page, okay? Any question on that? Everybody did a great job. You guys are like the first ones done, it looks like. So you did an excellent job. As soon as you save this, you can leave. You do not have to stay. And once you save, you can go. You did a great job. I hope you have a wonderful evening. If you have any questions, put them in the chat box or use your mic. Any questions, anybody? No questions. All right, raise your hand if you need anything. I'm going to go check out a couple of the other rooms that still aren't finished. Have a wonderful evening. Thank you very much for doing such a wonderful job, and thank you for attending the collaboration today. I hope you learned something here today. This is a good place to learn. Okay. Goodbye. Have a good evening. Okay, I see.
Once this is over, you know
Okay, I
I have
see
to worry about
Jordan has raised her hand here, right? So let's take a look and see what you got here. Very good. You start out with what's given. This is a parallelogram. All right. Now, the next part's a little tricky. Let me explain. You have all of the right statements matched to the right reasons. Okay. So you're saying that BAC is congruent to DCA, alternate interior angles. Okay. Here's the only thing that should be changed. Okay. Before we could say that these two angles are congruent, we have to show that AB is congruent to CD by the definition of a parallelogram. Okay? So what you're going to do is you're going to want to switch 2 and 3. All right? So once you switch 2 and 3, you'll be correct. Very good. All right. So we could say that these two, actually we could say they're equal and parallel. All right? By the definition of parallelogram. Now I can say that these two angles are equal. BAC is congruent to DCA by the alternate interior angle theorem. All right? Then I could say that AC is congruent to CA by the reflexive property, and that gives me side, angle, side. So excellent job. So guess what? You are done. All you need to do now is save it. Okay, so, I'm sorry, you're not done. You still have the triangle proof to do. I apologize. So, you still need to do the triangle proof. Okay, so in this one, all right, you're going to start off with what's given. You're going to end with what you're trying to prove. All right? You're going to start off with what's given. I'm going to underline that. That's a hint. All right, so get your names up here. Jordan, you can put your hand down. And
Okay.
I'll be back in a couple minutes because one of the other rooms has their hand up. Okay, let's see. I see that you have your hand up, Danielle. So let's take a look and see what we have going on. All right. So you're always going to start with what's given. Very good. Now we constructed an angle bisector. The angle bisector, all right? From that angle bisector, we learned a couple things, that xy is equal to yz. We're also learning that by a definite angle bisector, we can say that these two angles, XYA and ZYA are congruent. All right? So by the reflexive property, I can say that YA is equal to YA. All right? Now here's where we run into a little problem. All right? Where do you see angle, side, angle? I don't see angle, side, angle here. I see something else. Okay? What do we see here? Right, this is side, angle, side. Okay? Side, angle, side. Of a side, an angle, and a side. So now this is in the correct spot, but what allows us to say that these two angles, okay, YXA and YZA are equal? What allows us? We've already proven the triangles are congruent. So what is that last statement we need to put in there? Right, CPCTC. Very good. Excellent job. Okay. So guess what? You're done. All you need to do is save it. All right. So to save, you're going to click File. Okay. You're going to click Save. You're going to click Whiteboard. All pages. And then you're going to click OK. And Mrs. Robb has sent you that collaboration form again. So click yes to save it because you're going to need that form for the 00.00 assignment, okay? All right, so once you click OK, this box will open. Now this is the important part. You need to save this as a PDF. PDF. Do not save it as a WBD or any other way. It has to be a PDF. It's the only way your teacher can read it. All right? So save it as 306 your name and a PDF. And this is what you're going to send in as the 3.06 assignment. That collaboration form that was just sent to you, that's the 00.00 assignment. All right? Any questions? If you have a question, use the chat box. Type your name in. Type in whatever information you want in the chat box. Use your microphone. Any questions? If you don't have any questions, you can go as soon as you save. Okay? If you don't have any questions, you can go as soon as you save. Okay? Any questions? No questions. Okay, so I see some of you are leaving. Have a good night. You did a great job. And I will talk to you soon. What is the link at the bottom of the screen? That link is for the collaboration form that was sent to you. Okay? So if you want, you could try to use that link for your collaboration form, but it's easier to save the one that was sent to you. Okay? So if you did not save it, let me know. I can send that to you again. If not, you can go. And you're done. You did a great job. You have a question, Spencer? Did you save it, Spencer? Because if you saved it, you can leave. All right, very good. Yep, so if you saved everything, you can go. You don't have to stay here. You good, Spencer? Yes, okay, great. All right, Spencer, well, you have a good night. I'm going to go up into the last room that's working, help them get finished. Yes, you click saved, you can go. If you saved it, you can go. Very good. Have a good night.
No, Johnny, put that down.
Put it down, Johnny.
Yeah.
How we doing in here? All right, I see you've put two things in place, and those two things are correct. So let me just tell you, what you're given is that these two sides are equal. Okay? All right? So because we're told they're both x, y, and z are 3 centimeters. That's given. All right, so what's YA? We constructed a what? Look it down here. What did we construct? What is YA? All right, we should all be working together on this.
A bisector.
So, what do you think it is?
Would it be an angle divider?
Maybe. Worth a shot.
So what do you think?
I'd say angle divider, but
Okay, when did they ever talk about angle dividers in lessons? What lesson has angle divider?
I don't remember.
You don't
Don't
remember?
know.
Okay.
I don't
What?
believe angle divider has been anywhere, even though both words are known in our vocabulary. That's why she probably said angle divider.
Okay.
But I honestly believe it could be angle bisector.
Okay. So who else thinks it could be angle bisector?
Tells me rock.
Okay, so who's ever writing this, why don't you move in what you think is correct, okay? All right. Right, because if you look, you could save this if you haven't saved it already. This message is coming through. That's for the collaboration form, and you will need that. So you haven't saved it. If you haven't saved it, save it now. Save it to your desktop, okay? Right. So if you look in this proof, all right, look what it says here. It talks about angle bisectors, right?
Mm-hmm.
Okay. So try to use. What's great about about these paragraph proofs is use some of the information that's here that's going to help you, giving you clues. So, all right, so now we can say that these two angles are congruent, okay? All right, by the blank of an angle bisector. So by the what of an angle bisector do you think?
Definition?
Okay, definition. All right.
Is that right?
That's right.
Yeah, Mel's rock.
All right. So now we have some given. This is angle bisector, definition angle bisector. All right. That tells us that. All right. Definition angle bisector says that these two angles are equal. So now I have a side and an angle. So now it says the segment Y is congruent to segment Y because of the what property? What property says something's equal to itself?
Reflexive?
Okay, so why don't you put in what you think it is? Okay, so reflexive property. So now I know a side. These two sides are equal, these two angles are equal, and this side's equal to itself. So what do you think goes in the next? What do you think goes into the next part of this proof? What do you think? In this spot here.
Probably like the angle side angle, maybe?
Well, what do we have here? Do we have angle side angle? What do we actually have?
I think it's side angle side.
You think it's side angle side?
Yeah.
All right, let's look. We have this side, we have this angle, and this side. So what do you think? You think that's correct? Side angle side?
Yes, side angle.
All right. Very good. That's not there, right there. Very good. Okay. So now we've proven the two triangles are congruent. Now this is what we were trying to prove, these two angles. Right? And that's correct there. All right? So what statement can we now say that these two angles are congruent? We've already proven the triangles are congruent. So now how can we prove these two angles that are part of those triangles are congruent? What statement do we use?
Angle, well, never mind.
All right. What do you think we can use?
Triangle sum, wait, what is that? I don't even know what that is. At the bottom.
Triangle sum theorem is how all of them, I guess all the angles make 180 degrees, I think. I don't know if that's true.
Okay.
But no,
I'm going to tell you, it's not triangle sum theorem.
yeah, because we're not talking about like the angles.
No, you've already proven that the two triangles are congruent. So once you've proven two triangles are congruent, what is the only thing there that you can use if you look at your statements that are left?
Proving.
No, there's a statement. Proving is not what you're looking for. Right? This one should be sticking out at you like a sore thumb. This should be one that sticks right out at you.
It's not CPCTC.
Do you know what CPCTC stands for? What does that stand for?
No, it's not that. Never mind.
I didn't say it wasn't that. I just asked you if it what does that mean? Did any of you bring your notes to the collaboration?
It means corresponding parts of congruent triangles are congruent.
Right, very good. Who was that?
Me?
Who was that? Which person? I'm sorry. Okay.
My username is Luke, but my name is Catherine.
Very good.
Yeah,
CPCTC is the answer. Right. So very good. You finally finished. That's it. You're finished. You're done. So, what are we going to do now? We're just going to save it. We're going to save it by clicking on File, upper left-hand corner. And then we're going to click on Save. And then we're going to click on Whiteboard. And then this little window here is going to pop up. And then we're going to click All Pages. Once we click All Pages, once we hit All Pages, click OK. We're going to want this window will pop up and put it 306 in your name. All right? Mrs. Ortega just sent you the file again. If you haven't saved it, save this because this is the file you're going to be using for the 00.00 assignment. All right? You want to save this as a PDF. Okay? This is a PDF. All right? Don't save it as any other way. It has to be a PDF. That's the only way your teacher can read it. So save it as a PDF. Okay.
And then the file name would be what?
File name is 306 in your name. And once you save it, you can go. Okay, so once you save it, you can go.
Yes.
Any questions?
Nope.
Okay.
Thanks. Thank you.
You're very welcome. You did a good job.
We just exit now.
You could just exit now. Just click the red X upper right-hand corner. You can go once you've saved it.
Okay.
All right.
Sure.
Make sure you send this in to your teacher. You're going to send this what you saved as the 3.06 assignment. All right.
Bye.
Bye.
Don't close the laptop. Not the laptop.